going to jump right in here. So these are my basic rules. We've written these down before, so it's up to you if you want to write them down again. Remember what IFF means from the old lesson? If and only if. Ready? I have to throw them high so I don't like hit anyone in the face. If and only if. So if you have a number with the same base to a power, then those powers have to equal each other. So a to the x equals a to the y, if and only if x equals y. Same thing is true, log a of x equals log a of y. If those are the same base, then x equals y, right? We wrote those out. We also wrote out that exponential and log functions are inverses of each other. So if you take an exponential function and raise it to log base a, then they just cancel out, just like x squared and square root. And the same thing if you have log base a of a to the x. You throw in the ln stuff there too. Ln, that's what we're just struggling today. Ln of e to the x equals x. E to the ln of x equals x. All of those things are true. And just with any equation, remember, whatever you do to one side of the equation, you have to do to the other. So we've been doing that for years, so when we're talking about logarithms, we're kind of get to do some new stuff, like ln both sides, or e both sides. Okay, ready? Okay. The great thing is my kids didn't even realize I was taking candy from them. They just thought it was fun that they got to pick 20 pieces of candy. I don't know how many years I can get away with this. It's too much candy, really. Okay, so let's cover my little hint for this one. As we talk about other stuff on the test, there's always people that solve this a different way than just making them the same base. But I just want to show you like the first way that you can solve equations is just rewriting them, because if we can write them as the same base, then we could just set the exponents equal to each other. So they like to trick you a little bit and throw some stuff out there. You can't take 2 times 8 and say it's 16 because it's to a power. What you could do is we could divide by 2 there, and I could say a to the x equals 4. Could we write 8 and 4 both as a number to a power, like the same number to a power? 8 and 4 are both powers of whatever. 2, you get a piece of candy. 8 is 2 to the what power? 3, look at this. I better just get a pile of candy there. Should have worn pockets today. So we could say this is 2 to the 3rd x. Oh my goodness. Here's an easy one. 4 is what number? 2 to the what power? Squared. So if I can write these as the same base, all you have to do is set those equal to each other, right? If it's 2 to this equals 2 to this, then I can say 3x equals 2. Which I'm not going to get candy for that one. It's just x equals 2/3. And you can check. It really does work in the problem. So the first couple problems on your homework, they want you to make them the same base. So let's look at one that looks a little scarier, even though it's not that scary. This is some terrible fraction writing for me, but I'm going to rewrite it better. 3/4 to the x power equals 27 over 60. It looks scary because it's fractions, but I think it's less work for number 1. You just have to think about what we're trying to do. We're trying to write them as the same base. So look at this number, and look at this number. Is 27 a power of 3? Is 64 a power of 4? What power?
3.
So could I write this as 3 over 4 to 3 to the third is 27. 4 to the third is 64. What's the answer here?
3.
X equals 3. Oh my gosh, sorry. They were only all so easy, right? Look, I forgot to file candy. Someone's getting the gummy eyeballs. Just saying. Gross. Okay, there's gummy. I think there's gummy ears in there too.
I'll trade the sticker for a body part. Oh, it's a weird sentence.
Okay, what happens when I give you something like this? Can you write 10 as the power of 2? No, is the answer to that. So we have to have a better strategy of what we can do to solve problems, because we can't write every problem as the same base, because they're going to be ugly numbers. So does anybody remember from last year what you can do to get an x out of the exponent? You can't take the x root, because how would you take the x root of 10?
That was a good one.
Who else? What else? What else did someone say?
I said L.
If we ln it, if I ln this side, I have to ln this side too. Why would that be a good idea to ln it? But why would it? What could I do now if I ln both sides? Maybe something to do with one of those properties we learned last week. You have ln of a number to an exponent.
Add the exponent.
And I pull that exponent out front. So I like ln. You could log base 10 it also, right? So common log or ln, because those are buttons on our calculator. But yeah, when you have an exponent up there and you want to get it out, you can ln it. Whoppers, who likes whoppers? Gross. Oh my gosh, don't tip over. Right? So I can pull that out front, and then I'm just solving for x. So I'm going to just move that over by doing what? Divide by ln of 2. Who said divide? Sour punch straw? So a couple things to point out. ln of 10 divided by ln of 2 is not ln of 5. You can't cross out the 10 and the 2. The ln's don't cross out either. Like your answer is ln of 10 divided by ln of 2. And when I give you a quiz and a test that has questions like this, my directions are always going to say, give me the exact answer and give me the decimal answer. This is the exact answer, because when you type it in your calculator, it's going to give you a decimal. So this is the exact answer, and then I want you to type in your calculator to show me that you can get the approximate answer. And if you did log base 10, you'd get the same thing. Are you trying to give me the answer? Calm down on the sugar. Are you supposed to have this much sugar? I'm going to go 3 decimals, and I'm going to say 3.322. Did you get that, Maddie?
Yep, yes.
Okay.
I'm not typing. So. I'm a swimmer. I burn this off at the end of the day. So it's fine.
Okay, so we've made them the same base. We've ln'd both sides. There's lots of options here on this one. I think there's more than one way to solve this problem. Some good rules to think about is the properties of logarithms are really important. Adding and subtracting with logarithms isn't that much fun to work with in solving equations. So if you see addition or subtraction, a good thing to think about is putting them back together, or sometimes people think about moving one over to the other side. I don't know. What do you want to do? I'm open to options. Put them together using the property, or move one to the other side. Okay, you get the same answer either way. So is it okay if I add the ln over there? Ln of x equals ln of 5. I'm going to do it both ways just to show you. Could I also write that as ln of x divided by 5? Both two ways to think about simplifying that into one logarithm. I think that way is the easier way, but this way, just because if if we have log of something equals log of something, what's the property that we know is true? Okay, we wrote it as log base A. Log base A of x equals log base A of y, which means this has to equal this. Like if you can say ln of something equals ln of something, we can just say x equals 5 and we've solved that problem.
Is that right?
More willing to talk. All right, let me give you a second. With me on that? What if I didn't do it that way? Oh man, this makes me have to think a lot more, right? How do you get rid of ln? How do you undo ln? What? Yeah, e and ln are inverses of each other. So we e both sides. And when you e something, think about when you put e in your calculator. It gives you e in the caret, like it has to raise it to a power. So it's not that we're multiplying by e, it's that we're raising both sides to the power of e. So I say we're eing both sides. Just e it, that's what I like to say. There you go. Because if I e both sides, and I now have e to the ln of x over 5, those cross out, and I'm left with x over 5, and what's e to the 0 power? Am I still going to get 5 as my answer? I don't know. Multiply by 5, I still get x equals 5. Right? So kind of two strategies in that problem. Log equal to a log, or eing both sides to get rid of an ln. Kind of remember doing this last year? Both of those are really nice answers. So, look, it's like the never-ending problem. All right. So now, what about if we talk about logs with different bases? Again, there's two strategies to go about when you solve these. There's one, you can use the definition of a logarithm, and there's one that we can do just like we e both sides. We can talk about how we can do that as well. So let's talk about the definition first, because this is kind of a good thing to review for your quiz that you're going to have this week. Without a calculator stuff, you have to know if you have log a of x equals y, that's the same as rewriting it as what exponential problem? What would the exponential problem say? Say that again? Oh yeah, like you're doing the numbers, right? So like she's going and rewriting it, but it would be a to the y equals x, right? This is the base, this is the answer. That's over there. So she said we could rewrite this as 2 to the 5th equals x. Right? The base, the power, and then the x goes there. Oh my gosh, sorry. Better that one in your seat. Which if you do that, you just get 32 as your answer. Right? It's not a bad way to do it. Definition of a logarithm. If you see a logarithm, rewrite it as an exponential. Hopefully this is kind of in your head. But just to show you, I want to show you that just like you can e both sides, you can get rid of a logarithm by doing its inverse as well. And the inverse of log base 2 is 2 to log base 2, right? So just like you can e both sides, I don't really know if this is correct grammar, but I say we can 2 both sides because I can write this as 2 to the log base 2 of x equals 2 to the 5th, right? So it's whichever way you think about it, because if you 2 both sides, then this cancels out, and again, I'm just left with 2 to the 5th. So whichever way makes the most sense to you. So if you haven't already started, do number 6. Either way. So you can do the definition of a logarithm way, or in this case, you would 4 both sides. I'm going to come around and look at your paper, and maybe I'll give you candy. That would be easiest. So if you for this side, you have to for this side too, right? All right. So if you for this side, it's not that this is 1 to the 4th, it's 4 to that. So that would be 4 to the 1. Why do you have a big 4 on this side and a little 4 on this side? It should be big 4, right? It should be, if you take 4 and you raise all that next one. So that's going to be 4 all raised to the 1 power, not 1 raised to the 4 power. Like when you e both sides or you score both sides, it's the big number and everything else goes after that. You see what I'm saying? If you for this side, okay, so you did this 4 to the 1 equals this, right? So if you do this, you don't have to do this one violently. All you have to do is solve this equation. 4 equals 1 minus x. Right? So you don't have to do it both ways. You can do it one way or the other. Did I give you candy? Okay, so I wanted to show you both ways. Flashing motion. Just so you know, this is probably going to be gone by tomorrow at this rate. So, like, by the time I do this in all my classes. You have to go right now. Did I give the time to shoot that in here? And I think that, hold on, I think it, hold on, I didn't see that. I don't think you need to do all that. I think I cut it in half. You check on the things like, I want to say it's cut off like right here, but I'm not sure. But definitely do that part. Okay. Okay. So I don't care which way you do it. If you do the exponential way, 4 to the 1 equals 1 minus x, right? Now you just solve that. Subtract 1, divide by negative. If you for both sides, don't forget that the 4 is the big part. So that cancels out, and 4 to the 1 gives you 4. And you notice it's the same equation, which is why I want to show you both ways, because it's whichever way makes the most sense to you. Okay? Oh, man, we got more. How many more of these do I have? Is the real question. Okay, that's it. Probably not. If you see an ln or an e or even a log, really good step to remember is let's get that e by itself before we start lning things, right? Because most people know when you see an e, you're going to want to ln. When you see an ln, you're going to want to e. before you do that, let's get e by itself. So I'm just going to add 14. And that would leave me 3e to the x equals 25. And again, I would not use decimals until the very end. I want exact answers. So when I divide by 3, like just write that as 25 divided by 3. And if I see e, the inverse of e is ln. And so just like you can e both sides, you can for both sides, you can ln both sides, because the ln of e cancels out. And my exact answer here would be ln of 25 thirds. And then I would type it in my calculator and get the decimal. So just really good habit to start writing the exact answer and the decimal answer. 25 divided by 3, all in parentheses, you should get 2.120.
So on questions like these, you're looking for 2 answers.
Yes. And on the test, I'll be looking for 2 answers. Again, we have some options on this one, but anybody have a suggestion on number 8 of something I could do? You could definitely e it first because it's just ln of a problem, right? The ln by itself. You could also rewrite that as a power of 1/2 and pull that 1/2 out first. Either way would work. But if you e both sides, right, that's going to become e to the first. If that was a 7, that would become e to the 7th, not 7e. That's probably the one mistake that happens when people are eating things. You said you wanted a body part, so. And then what happens here, this cancels out, and I get the square root of x plus 2 equals e. Yeah, to undo square rooting something, I'm going to square both sides. So I get x plus 2 equals e squared. And then I'm just going to subtract 2. Remember, e is just a number. So I just get e squared minus 2. That would be my exact answer. And then I can type that in my calculator. E squared minus 2 is about 5.389. I don't know where to get it. If I find it here, I'll save it for you.
Okay.
Questions about that? Again, there's a lot of different types of problems on your homework. I tried to give you 8 really different examples, but there's even other stuff. So you just have to kind of look at them and think, what are my strategies? Tomorrow, they're going to get a little uglier, a lot uglier on some of the problems. Those don't happen very often, but tomorrow they will get uglier on those. So we'll just skip that. So this is, what is this? 3-5. I do know on the homework sheet, there's a lot more homework. It's because I broke this up into 2 days. So on your homework sheet, if you go by that, you can kind of just draw a line. 1 through 17 odd, that's today's homework. Odd problems mean definitely you can check your answers, but it means that there should be work with those, right? If I pick one of these for a homework quiz, having an answer alone is not going to get you credit on the homework quiz, because I know the answers are in the back. But check your answers, because that way you know whether or not you're doing them correctly. And then tomorrow we'll do day 2 of this, which are a lot uglier problems. I won't really see you on Wednesday, but then on Thursday you're going to have a quiz. And you have homework quiz to take still from when you were gone.